Hi there, welcome to the unit circle part 2. If you haven't seen part 1, please watch that first. It's essential before continuing on with this one. Let's get deeper into work with unit circle in this video. To begin, let's recap some key concepts from the first video. We have a unit circle, a circle with radius 1. We know to find a coordinate on that circle, we take cosine of this angle to find the x value, and sine of this angle to find the y value, and then we have the coordinate. We also talked about tangent of an angle being equal to sine over cosine of the angle. We gave the equation of this unit circle, and we noted that since x is cosine theta and y is sine theta, that the equation of the circle you can replace your x and y with cosine and sine, and we came up with what is called the Pythagorean identity from that. Some key ideas. Pause if you need to kind of get those back into your mind. Now let's look at another thing we left off with. We saw when you spin an angle in a unit circle, like an angle 45, again we can find this coordinate by finding the cosine and sine values, and we found out that coordinate is 0.707, 0.707. These are identical because we have an isosceles triangle there. We can also find those same points, similar coordinates using same triangle, so that 45, 45, 90 triangle here can be put in this quadrant, the second quadrant, and in that case we have to spin an angle of 135 to get here. But this triangle and this triangle are identical. So when we do cosine of 135 and sine of 135, we find out that we get the same values as here. See, 0.707 and negative 0.707. Why negative here? Because these are negative x values here, right? These are positive x values, these are negative x values. So that number is the only one that changed, but it's still the same value in terms of length. So now the important thing there was that that's a coordinate of this location here. That's the coordinate, and then we notice that this cosine of 135 sine 135 is the same as negative cosine of 45 and sine of 45. So important to note that these two produce the same value of 0.707, and it makes sense because they both produce that same positive y value. Whether it's here or here, it's the same y value. But the x value had to become negative, so we have to do negative of that value. Okay, that's just a recap of important things we've seen. Let's take that forward from here. So here's another circle, unit circle. This time we spun an angle of 30 here. And the question is, what angles, so the same idea, what angles will create the same triangle in the second quadrant, third quadrant, and fourth quadrant? So what are the three angles that you'll spin from here to get the triangle to be here, here, and here? Let's take a look. The answers are 150 will get you to here, so it creates the same triangle. See the 30 degrees here? It's 30 here now, so that triangle has been like flipped over that axis, but we see 150 got us there. Next one, in the third quadrant, to get a 30-degree angle here, so that triangle now sitting down here, 30 degrees, we had to spin 210 degrees, 180 to here, and then 30 more to create that triangle. So I don't have the lines here, but that line would be like this, and in this triangle, that line would be going straight down like that. You always take the perpendicular to the x-axis, so you always draw it like that. Okay, now fourth quadrant, now we are in this quadrant. To get that same triangle, which is kind of like a mirror image up and down here, we can get this triangle here. So that angle must be 330 degrees to get you here. 360 would complete the circle. Okay, if you were able to do that, then you have a pretty good understanding of what we've been doing with the unit circle so far and the angles. So looking at those three, let's fill this in. What do you think? Sine of 30 is the same as sine of what? If you punched in your calculator sine of 30 and then did sine of some other angle, what other angle would it have to be to give you the same value? Well, I hope you see that one as 150, because again, if you had this triangle right here, right, 30 degrees, so that's sine of 30 would be, sine again gives us the y value, right? So if you had this right triangle here and you did sine of 30, you're getting this distance here, the y value. So the only way to get the same y value is if you go over here and you do that one here, right? That y value is the same as this y value. They're both the same height above the axis here. So that means it would have to be sine of 150. Okay, I hope that makes sense. Let's look at this next one. Cosine of 30 would equal cosine of what angle? Okay, maybe you got 330. We'll take a look at y in just a moment. Final one. Cosine of 30 equals cosine of what negative angle. And remember, when we spin a negative angle, we don't go this way, we go the other way. Well, hopefully you got negative 30 degrees there. Let's take a look why. So cosine of 30, I'm drawing it in this triangle. Here's 30 degrees, so if I had a triangle there, remember cosine represents the x value. So you wouldn't be looking for this length here, you'd be looking for this length along the x-axis. So if we're looking for an x value that is the same as cosine of 30, we need something that has the same distance here down here. The only way we can get the same x value is either up here or down here. They both have the same x value. So cosine of 30 is the same as 330 because you have to go 330 to get here, and then it's the same x value here, that same x value if you have the two triangles. And then if you go negative direction, so negative means go this way, instead of going 330 this way, you go from here this way, negative 30. So negative 30 from here to here, and that produces this triangle again, which ends up giving you the same x value as here. Okay, this is, once you understand this, it's easy, but when you're looking at it for the first time, maybe it might be a little tricky. So make sure you pause and really study this if you're having trouble understanding what's happening. Okay, so there's some rules that come out of that. When we have sine of an angle, it is equal to sine of 180 minus the same angle. And that's what we see happening here. We had sine of 30 produces this y value, and sine of 150 also produces that same y value. Therefore, sine of 30 equals sine of 180 minus 30, right? It's always 180 minus the same angle gives us that. So that rule comes from that diagram. Take a look. This rule, the cosine rule, we have cosine of some angle equals cosine of negative angle, and that's what we see happening here. Cosine of 30 was the same as cosine of negative 30. So with cosine of 30, the x value here, x value, is the same as if you go negative 30, the same x value here. Okay, let's see if you really understand that. I'm going to pose two questions for you, one about sine, one about cosine, and your job is just to find another angle that gives you the same sine and cosine value. Okay, now that you've tried that, we're going to do more like that in a minute if this is still confusing for you, but let's look at one more rule. We looked at our rule for sine angles and cosine angles. Let's look at one for tangent. As you may remember, tangent of an angle is the same as sine of the angle over cosine of the angle. So let's say we had a point right here where my mouse is now, the cursor. That would be a positive x and y value. That means a positive sine and cosine value. That means if you did tangent, it would be a positive divided by a positive, which would give you a positive tangent value. So over here we'd have a positive tangent value. Where else would we have a positive tangent value? Which quadrant? Okay, as you were thinking about that, hopefully you thought, okay, maybe the third quadrant, because in the third quadrant, imagine this point, that is a negative x value and a negative y value. So if you divided those two negative values, sine and cosine, you would get a positive again. So you get positive tangent here and also here. If you were here, the tangent would be negative because x is negative but y is positive. So you would end up having a positive divided by a negative. And if you went here in this quadrant, you would have a positive x but negative y. So one's positive, one's negative, and it will give you negative tangent. So these two are negative tangents, these two are positive tangents. So the rule for tangent then is if you have some angle, here's the rule. The rule is if you have some angle, it is equal to tangent of 180 plus that angle. So in other words, if you had an angle here, you would have to go 180 degrees halfway around to get somewhere in this quadrant to get another positive tangent value or equal one. So that's the rule for tangent. Those are three rules. But on the other hand, I often don't show these rules to students. They happen to be here, but because once you start memorizing rules, you stop thinking about the unit circle logically. If you always just remember about spinning angles and knowing when it's positive y, positive x, negative x, you can come up with anything you need. Just remember spinning around and whether you're in positive, negative for x and y. Okay, let's go back to radians for a moment. We talked about radians in the last lesson. 1 radian was given as the angle measure when the length of a radius is wrapped around the circumference of a circle. And we found out that there are 2 pi radians in one circle. Therefore, 360 degrees is the same as 2 pi radians. So all the way around the circle can be said to be 360 degrees or 2 pi radians. So how much would be 180 degrees? Well, that would be pi radians because you're halfway around the circle, so half of 2 pi. Halfway around the circle, pi radians. How about 90? Well, it's pi over 2 radians because now you're doing half of pi. So you're going half of pi, which is, well, that's half of pi. How about 45? Well, now we're talking about 1/4 of pi, because if a half circle is pi, then 45 is 1/4 of the way. So 1/4 of the way to the halfway mark, pi over 4 radians. We'll talk more about that later, but for now, let's try that in some problems. So here's an idea. Here we have, again, an angle, but instead of giving us in degrees, it gives us the angle of radians here. It says pi over 3. So think about that. Pi would be halfway around the circle. So pi divided by 3 is what angle here? Well, pi over 3 is the same as 180 divided into 3 parts, because pi is 180 degrees, right? And that is 60 degrees. So we know that this angle must be 60 degrees. So if we were to find this coordinate here, we can do cosine of pi over 3 sine pi over 3 if we have our calculator in radians. Or we can say, well, I know this angle is 60, so I can just do cosine of 60 sine of 60. This in radians and this in degrees, if you punch in your calculator, you should see will give you the same values. How about you give it a try? Try cos 60 and cos pi over 3, changing your calculator from degrees to radians, just to confirm. Alright, so that's the coordinate of that point. Now let's use that idea and go a little further. It says find the obtuse angle that has the same sine as the given acute angle. So imagine you have an angle of 70, so draw your circle. Try to draw this on your page. It's important to draw the unit circle every time. So you draw a unit circle, then you put an angle of 70 in it. So maybe you have something like this. Alright, there's from here to here is 70 degrees. Okay, and now it wants you to find another angle that has the same sine value. And remember, sine represents the y value. So think about, this is your y value here. Where would be another angle on here where you spin it where it has the same y value, the same positive y value, right? This is a positive y value. So you have to stay in the upper part of the circle because those are positive y values. Okay, let's check. Well, that angle would be this angle. You have to put this triangle over here. Now you have this 70 that was here is now here. And you have a triangle that has the same height, which is like your y value, right? So we have the same y value here and here. So that angle is 110. So that tells us sine of 70 equals sine of 110. And if you're thinking about that rule, the rule said sine of 70 would equal sine of 180 minus 70, and that's 180 minus 70 is 110. But it makes sense. Again, think of it in terms of the circle. Much better to know it this way. Okay, how about the same sine angle that gives you pi over 4. If pi over 4 is your radian angle, what would be another angle that gives you the same sine value? Again, you're thinking, I'm trying to get the same y value. Okay, so here's your unit circle. This could be pi over 4. Pi over 4, you're thinking pi divided into 4 parts. So half the circle divided into 4 parts, that must be 45 degrees. But I kept it as pi over 4. So I need the same y value. Same sine value means same y value. So I need the same height. I need a triangle that has the same height as this one. So here's this one. I need to draw it over here because that has the same positive y value right here. So pi over 4 goes here because pi over 4 would be this corner here in this triangle, and now I made a reflection of it, so pi over 4 is here. So that new angle to get me to this new triangle is 3 pi over 4, because if the leftover here is pi over 4, then to get there I need to do, like, imagine pi divided into 4 parts. Well, if one of the parts is here, then this must be 3 of 4 parts here, right? 3 of 4. So you go pi over 4, pi over 4, pi over 4, pi over 4. There's 4 parts there, and we have 3 of those parts to get to here. It's a fraction. Together it has to make 4 over 4 pi, which is just pi. Okay, anyway, hopefully you're able to figure that out in terms of fractions. There's our angle, same sine value, because our y value here is equal to this y value here. Both are in the upper part of the circle because those are the same positive y values. So that means sine of pi over 4 equals sine of 3 pi over 4. Okay, try this one. Now we're looking for a cosine value that gives another angle that gives the same cosine value. Take a look at this one. Here's our first triangle was here, 50 degrees, and now I need the same cosine value, means the same x value. So we need the same positive x value. So now I'm drawing a triangle down here with 50 degrees because that gives me the same x value right here. Alright, and then that would be 310 degrees to get there. So the answer to that one is cosine of 50 equals cosine of 310 degrees. And now finally we need another angle that gives the same cosine value as 2 pi over 3. So here's our circle. Here could be 2 pi over 3. Why is that 2 pi over 3? Because we have 2 out of 3 parts. if pi is broken up into 3 parts, we've gotten 2 parts there. That is that angle, and the other angle then is 4 pi over 3. Take a close look, make sure you understand that.